Good afternoon or late morning, everybody, depending on where you are. This is Nelson Wu. I'm an application engineer and support manager at Motionport. And the presentation that I'm going to go over today has to do with the new developments to the toolkits, controls, and co-simulation interfaces in the new version of RecurDyn V9R3. So just briefly, the things that we'll be covering today. Well, the first thing will be RecurDyn DriveTrain toolkit, which is a new toolkit, and we'll be covering a lot of that. And then we'll be briefly covering some of the other changes to the other toolkits, including the Particleworks interface, the EDEM interface, the elastrohydrodynamic bearing and lubrication toolkit, controls and CoLink, the chain toolkit, and then the roll-to-roll toolkit. And then there are a couple other miscellaneous enhancements after that. So just to give an overview of the new DriveTrain toolkit, the target uses of this toolkit are to simulate the drivetrain, which could consist of gearbox, which could have gears, bearings, and shafts. And typically you would find these in transmissions and speed reducers. And another application would be electrified powertrains as well. Some of the main features of this interface is the interface to a software called KSSoft. The advantage of using KSSoft is that it has it's a software that focuses on gear and bearing modeling, and it has a gear analytic contact. So it's taking into account the very detailed geometry of the gears and performing analytical calculations to provide very accurate contact results. And then also there's an embedded KSSoft GUI within DriveTrain toolkit, which will allow for gear analysis. Another main feature is basically the dynamic analysis of the drivetrain. So together with RecurDyn dynamic analysis and the KSSoft static analysis, this is a really powerful combination that will help to understand the behavior of the whole drivetrain as a system. Another main feature is the multi-flexible body dynamics. In this toolkit, the shafts are modeled as flexible bodies using beam elements. And then flexible bodies can also be attached, such as the housing, so you can include those vibrational characteristics of that as well. And eventually, RecurDyn durability and acoustics will be able to be used. Also, another main feature is the noise vehicle vibration and harshness analysis. And using the camel diagram, you'll be able to do order of tracking analysis. So just to go over some of the main advantages of the drivetrain toolkit, the first one is accurate gear analytic contact. And why this is important is because transmission error is a very can be a very small, measured in very small units of length, and so the accurate contact calculation is crucial to this type of analysis. Function Bay provides this accurate gear analytic contact through technical cooperation with KSSoft. KSSoft is, again, it's a program for sizing, optimizing, and recalculating designs for machine components, such as gears, shafts, and bearings. And so the advantages of the gear analytic contact of the RecurDyn drivetrain toolkit are that with KSSoft you have theory-based contact calculation, which considers all the detailed gear design parameters. It also takes into account the deformation of the gear teeth and the tolerance of the gear teeth as well. And again, we're making this contact available within the dynamic solution of RecurDyn. So another main advantage is the easy modeling within the specialized user interface. So you have an easy way to model the gears, bearings, and shaft through specialized dialogues. Some of these dialogues are shown below. So this one here is the cylindrical gear modeling diagram from KSsoft. And so you can basically enter many detailed parameters of the gears. This is an example of the KSsoft bearing modeler dialog. And then here's an example of the shaft modeler. Another advantage is that various bearing libraries can be used. And so in these libraries included are 15 different types of bearings. Bearing databases of 8 global brands are all included, and those brands are shown here at the bottom of the screen. So there's SKF, Koyo, Timken, and all these other ones as well. And essentially the bearing creation ultimately can be performed with tens of thousands of libraries. Another advantage is the ability to model the entire system of the gear of the drivetrain. So we're not just simulating components here, we're simulating the entire system, and that allows us to understand the interaction between all the individual elements. And also assemblies can be modeled as flexible bodies. Another main advantage is being able to perform transient analysis using a dynamic solver. The literature survey has found that the most relevant transmission error measurements for noise and vibration predictions are the dynamic type. It's really important that when you have these simulations where they're dynamic, that you can include all the elements of the model, such as the gear, bearing, shaft, and housing, and that they be measured in or simulated in the operating condition that they would actually be used in. So this is especially true of high-speed systems. And various causes of gear misalignment can be simulated, such as initial assembly error, shaft deformation, bearing stiffness, and housing deflection. Another main advantage of RecurDyn DriveTrain Toolkit is the various post-processing functions that are available. And so one of them is that you can check the transmission error. And this is an example plot showing this error here. And you can see that the length magnitude of this error, it can be quite small, on the order of microns. Another type of post-processing is using the Campbell diagram, where you can perform order tracking analysis. This helps to identify the frequencies of major contributions to vibration and noise, and this essentially helps you diagnose which part of the system to address. Other post-processing functions include contact pressure, tooth stress, and deformation. Here are some examples down here showing contact pressure and tooth stress. And then you can also check the effects of gear backlash, review the vibration of the system to analyze the rattle and whine noise, and also analyze the deformation and stress of the shaft. So the general process for using RecurDyn DriveTrain is shown here. So the first step would be modeling, build the components, which are the shaft, bearing, and gears. Next, you would simulate, and then the third step would be post-processing. So here are the RecurDyn program, and looking at the interface at the main menu, these are the available functions that are all part of the gear training toolkit. And so the first set of functions are shaft, shown here on the left here. This part of the software includes an intuitive shaft modeler, easy and convenient modeling. Flexible shaft using beam elements is used to calculate the deformation and torsion. And then 3D visualization of the beam shape is used based on the beam properties. And then you can also automatically create connections using FDR or RBE elements where the shaft connects to the gears and the bearings. Let's see. Okay, so we're still talking about shaft modeling. One thing is that it can support planetary shafts, and also there's a what they call a shaft scope, which you can use to check the deformation of the shaft as well as other results. And I'm just going to play a little demo of how you would actually perform some of the modeling tasks for the shaft. So right now they're defining the endpoints of the shaft. So you can see that some of the points are being defined on the screen. And then some of the properties of the different sections of the shaft are being defined here. So you've got length, the radius, and then also the element size of the beam elements used to model the flexibility of the shaft. And then here we're defining some of the connections between the shaft and some of the other elements, such as bearings and gears. And then once they click OK, you can see that that bottom shaft has been modeled. And the length of the beam elements you can tell by the segmentation of the shaft there. All right, so this next animation is going to show some of the post-processing that's available with the DriveTrain shaft toolkit. So what's being displayed here is the von Mises stress contour plot for those for all the shafts. And then here we're going to take a look at the specialized shaft scope that I mentioned earlier. And so you can, as you play the animation, you can see how the stress distribution along the shaft changes. So the next module in the DriveTrain toolkit is the bearing toolkit. And it's actually called BearingKS, which means that this is part of the toolkit that's integrated with Ksoft. And so what this toolkit provides is an intuitive bearing modeler, and the bearing creation is performed using input parameters. So an example is shown here, lower right portion of the screen. And then you can also estimate internal geometry parameters of the bearings based on diameter and load rating of the ball and roller. And then the toolkit provides the position, velocity, acceleration, and reaction force of the bearing at each point in time throughout the analysis. 15 types of bearings can be simulated, and the databases of 8 global brands of bearing manufacturers is included. And so here are some of the examples of the different options you can choose as far as the bearing type, and you can even choose the exact bearing model for each particular manufacturer. here, this is going to be a demonstration using the bearing toolkit to do some of the modeling tasks. So we're starting out, we already have the shaft model from the previous step. And so right now, they're inputting the parameters for where the gear is, where the bearing is located. Then we're choosing some of the different gear parameters and as well as the bearing type. And then once he clicks OK, then you can see that that particular bearing has been created at that location. So the next part of the toolkit has to do with modeling gears, and this toolkit is called GearKS. Again, this is part of the toolkit that is has KSoft integrated. So this part of the toolkit provides the gear analytic contact, which is specialized for a gear analysis. With this type of analysis, the SMP, or the symmetric multiprocessing, is available. And in RecurDyn, you can use up to 16 cores to speed up the simulation. This also provides various gear analysis results, including transmission error. Different types of gears are supported, such as spur gears, helical gears, and planetary gears. And gear geometry and detailed tooth modeling are supported. You're able to include various types of tooth tolerances, and these are available as libraries. And then also material libraries can influence deflection and contact stress results. Automatic calculation of gear backlash is performed based on these inputs. And then detailed modeling, analysis, and post-processing through the built-in KSoft user interface is also available. And this allows for the precise gear design with the parameters used for actual gear design. And all of this is interoperable with the gear models of RecurDyn. And this also supports gear static analysis and various results such as stress distribution on the gear tooth surface can be obtained. So this is a demonstration of using the GearKS toolkit to model some of the gears. So right now, they're inputting the location of the first and second gear that are part of this gear train. And here we're defining the gear type to be a right-hand helix gear and defining the number of teeth and other dimensions. And then here we're defining the interaction between the two gears. And also you can see that the backlash can be automatically calculated. And so then after he clicks OK, then you can see that two gears have been created inside the model. And then this is a demonstration showing the embedded KSoft GUI. So starting with a gear pair of the cylindrical gear group 2, he's opening up these parameters that can be adjusted. So you can see there are quite a few detailed parameters that can be input and taken into account for the analysis. And right now he's performing one of the available analyses after inputting some of the parameters. So that's showing the contact stress between the teeth and looking at some of the contact points along the gear. And then this is showing some results for the tooth root stress. Now we're going to move on to some of the other toolkits. For the Particleworks and EDEM interface, there's a new feature where you can define sort of a volume where you can clip the particles. So this helps to kind of let you only visualize the particles that you're concerned with and ignore the other particles that might be getting in the way of what you want to focus on. For the RecurDyn control and RecurDyn CoLink interfaces, RecurDyn control in V9R3, the direct interface with AimSim is now obsolete, and that's been replaced with FMI, which is the functional mockup interface, which is a standardized way of allowing different programs to communicate between each other. The multi-cosim, which is a feature which allows for co-simulation between more than two other software tools. This now supports CoLink. And for CoLink, CH scripts is now obsolete, and instead Julia script is supported. So there have also been some changes in RecurDyn V9R3 to the hydrodynamic lubrication. And so now in V9R2, there used to be this rotational lubrication and piston lubrication options. And this has been split into 3 different options. And in V9R3, basically some more functionality has been included here. One of the options is that a cone-shaped geometry can be supported. So here you can enter in a second diameter to model that cone shape. Oil hole and groove effect settings can be input. Also, the flexibility of the bearing and shaft can now be incorporated into the simulation. Yes. Okay, so moving on to the RecurDyn chain toolkit. A user-defined bushing position can now be defined. And here, so basically, when you introduce this offset, you can see that influences how chain will deflect laterally. And then another feature is that instead of defining the mass of the individual chain segments, there's an option to just define a total mass for the entire chain, and then that total mass will be distributed evenly to each of the chain links. The next toolkit is the RecurDyn roll-to-roll toolkit. This is a two-dimensional modeling toolkit where you can model flexible sheets or other material that's typically wound on one roll and then unwound on another roll for storage and processing. And one of the changes made in V9R3 is that when you're modeling the winding, you can define whether or not contact between self-contact with the flexible element is defined. So on the left here, you can see that contact has been turned off, and so it's just winding up at the same radius, regardless of how many revolutions have occurred. And the main advantage of this helps to speed up the simulation. And on the right, this is where that option has been turned on to include that contact, and that's so then here the advantage here is that you have a more accurate simulation where the radius changes as the number of revolutions occurs. Just some of the other enhancements that were made in ProcessNet. ProcessNet now supports the frequency response analysis and also geometry export. And then there are also a couple new tutorials. One is the acoustics tutorial, and then there's also a new Particleworks interface tutorial.